Hello students, welcome to my class Introduction. Class Standard 12, subject है Mathematics first paper, chapter name Permutations and Combinations. Exercise 5A, lecture 1. Today's lesson, addition and multiplication rules of counting. To explain the permutations theory, explain n factorial, and 4 number, prove and apply the different formulae for determination of permutations. At first we have to know addition and multiplication rules of counting. So addition rule, if one work can be done in m ways and another work can be done independently in n ways, the two works can be done in m plus n ways. Suppose that there are three separate or three roads for going from A to B on foot, that's mean this, and this, and two roads by the bus. A man can go from A to B on the foot or by the bus in 3 plus 2 equal to 5 ways. Okay. That's mean the man can go from place A to B in this way by foot or this way or this way, and the man can use this way or this way by bus. Okay, that's mean total 5 ways. 1 2 3 4 5, total 5 ways he can go from A to B. This is a addition rule of counting. Multiplication rule, if one work can be done in L ways and second work depending on the previous work can be done in M ways, the total number of ways of doing the two works together is L into M. Again, a third work depending in the previous two works can be done in N ways. Then the total number of doing the three works together is L into M into N. Suppose that there are three separate roads for going from A to B and two separate roads for going from B to C. So a man can go from A to C via B in 3 into 2 equal to 6 ways. Okay, that's mean the man can go from A to B in this way or this way or this way. That's mean he use this path or this path or this path. Okay, and from here to here he can use this way or this way. Okay, that's mean the man can go from here to here in 3 ways and here to here in 2 ways. But for this way, that's mean he can go from here to here in 1 way, and from here to here, that's mean from B to C, he can go in 2 ways, that's mean this or this way. Similarly, for second path, he can go from B to C in 2 ways, and third path he can go from B to C in 2 ways. Therefore, for first path he can use 2 ways, second path he can use 2 ways, and third path he can use 2 ways. That's mean this or this. That's mean total will be 2 plus 2 plus 2. That's means 6 ways. This is a multiplication rules of counting. Clear? Now definition of permutation. Each of the arrangements that can be made out of a given number of things, taken some or all of them, is called a permutation. Permutation, one kind of arrangement. Okay, for example, the different arrangements of three different letters A, B, C, taken two. Taken two mean not all. That's mean taken some. Some mean not all. Okay. At a time are A, B, B, A, B, C, C, B, C, A, A, C. Okay. That's mean from three different letters we arrange taken two A, B or B, A, B, C or C, B, C, A or A, C. That's mean total arrangements or total permutations is 6, and which can be written as 3p2. 3p2 mean from three different things taken two number of permutations. That's mean 3 permutation 2. Okay, and we can write 3p2 this equal to 6. Again, the different arrangements of three different letters A, B, C taken 3. Taken 3 mean taken all. Another condition, taken all. Okay. As here is three letters, taken 3 mean taken all. Clear? At a time are A, B, C or A, C, B or A, B, A, C or B, C, A or C, A, B or C, B, A. Total number of arrangements or permutations is 6, which can be written as 3p1. That's mean number of things 3 taken all. All here will be 3, not 1. Okay, therefore 3p 3 not 1 equal to 6. Factorial. If n is any natural number, then factorial n denotes the product of all natural numbers from n to 1. The factorial of a natural number n is denoted by the symbol n factorial. Therefore, n factorial mean product from n to 1. That's mean n to n minus 1, n minus 2, n minus 3 dot 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 3 to 1. This equal to we can write n into n minus 1 factorial. As n minus 1 factorial mean product from n minus 1 to 1. Okay. Also here n is present. So n into n minus 1 factorial mean n into n minus 1, n minus 2 dot 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 3 to 1. Also this equal to we can write n into n minus 1 into n minus 2 factorial. N into n minus 1, here also present n into n minus 1, but n minus 2 factorial mean product from n minus 2 to 1. That's mean from here to here. That's mean this equal to we can write this. As for example, 5 factorial mean we can write 5 into 4 into 3 into 2 into 1. All are natural number and product from 5 to 1. And this equal to we can write 5 into 4 factorial. 4 factorial mean product from 4 to 1. And this equal to we can write 5 into 4 into 3 factorial, or this equal to we can write 5 into 4 into 3 into 2 factorial. Okay, and this equal to we can also write in the general form. That's mean like this form, and we will get 5 into 5 minus 1, 5 minus 2 dot dot 2 into 1 for matching this. Okay, this equal to we can write 5 into 5 minus 1. 5 into 5 minus 1 into mean n into n minus 1 factorial. Okay, this equal to we can write 5 into 5 minus 1 into 5 minus 2 factorial. That's mean 5 into 4 into 3 factorial. Here 5 into 4 factorial. That's mean this and this. Okay, and this same form. Again 8 factorial mean product from 8 up to 1. That's mean 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. That is equal to 8 into 7 factorial. That is equal to 8 into 7 into 6 factorial. Or this equal to, we can write 8 into 7 into 6 into 5 factorial, or etc. You can write, no problem. Some theorem related to permutation. The number of permutations of n different things taken are at a time is NPR. Okay. The number of permutations of n different things, that's mean n all are different, taken are at a time is equal to the number of ways in which our places can be filled up by the n things. And as this equal to NPR, so NPR this equal to n into n minus 1, n minus 2, n minus 3 dot 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 n minus r plus 1. That's mean first place can be filled up in n ways, second place can be filled up in n minus 1, third place can be filled up in n minus 2. That's mean first two place can be filled up n into n minus 1, first three place can be filled up into n into n minus 1, n minus 2. So first r places can be filled up n into n minus 1, n minus 2 dot 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 n minus r plus 1, where n belongs to natural number and n greater than or equal to r. That's mean n always greater, but sometimes that are also equal. Okay. And the permutation will be all are different. Okay, that's mean no repetition. For clear concept here, 3p2, that's mean from 3 different things taken to number of permutations or arrangement, this equal to 6. This equal to, we can write 3 into 2, that's mean first place can be filled up in 3 ways and second plus can be filled up in 2 ways. This equal to, we can write 3 into 3 minus 1. And for matching with this, we can write 3 into 3 minus 2 plus 1. As here is 3 and here is 2, so here will be 3 minus 2 plus 1. Also here n and here r, that's mean n minus r plus 1. Okay. And follow the diagram. First place can be filled up in 3 ways, but second place can be filled up in 2 ways because repetition not allowed. Okay, so if 3 different things mean 1, 2, 3 are 3 different things, first place when you will fill up by using 1, second place will be 2 or 3. So second place can be filled up in 2 ways. Okay, as no repetition. Remember this. So first place as number of things 1, 2, 3. So you can use 1 or 2 or 3, but second place you can use only 2 digits because after fill up first place you have to fill up second place. So as total different things are 3, so second place will be filled up in 2 ways. So first 2 places will be filled up in 3 into 2, that means 6 ways. Clear? Okay. Corollary, if r is equal to n, then from 1, that's mean equation number 1 was NPR. As r equal to n, so here will be n equal to n into n minus 1, n minus 2, n minus 3 dot 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 n minus, there was r but here will be n because r is equal to n plus 1 minus n plus n cut, here will be 1 and before 1 will be 2, before 2 will be 3, before 3 will be 4, That's mean this equal to, you can write up to this same, and this equal to 3 into 2 into 1, this equal to 1. Before 1 I have said 2, and before 2 3, and before 3 will be 4, and etc. And here is product from n to 1, and we know product from n to 1 mean n factorial. Clear? Therefore npn this equal to n factorial. That's mean this and this are equal. Corollary to from 1 again, npr this equal to this. Now multiply both numerator and denominator by n minus r factorial. Okay, n minus r factorial. As here is n minus r factorial and started from n, so n into n minus 1, n minus 2 dot 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 n minus r plus 1 into n minus r factorial mean n factorial. So numerator will be n factorial and denominator will be n minus r factorial. Therefore npr, that's mean this equal to n factorial divided by n minus r factorial. Most important formula, I have to remember this. Okay, now putting r is equal to n, r equal to n, will get n factorial divided by n minus n factorial. N minus n factorial mean 0 factorial, and numerator same. This is equation number C. Now from a npn, left side npn, here also left side npn. Therefore n factorial divided by 0 factorial, this equal to 1 factorial. Okay, this line, follow this line from a and c, n factorial divided by 0 factorial, this equal to n factorial. Now alternando, n factorial into, convert n factorial into here and this into here, will get this. That's mean n factorial by n factorial, this equal to 1. That's mean 0 factorial, this equal to 1, we can write. And here note that npn, when you'll put n is equal to 0, we'll get n factorial divided by n minus 0 factorial. That's mean n factorial by n factorial, this equal to 1. You have to remember this. Now follow permutation of things not all different. That's mean not all different. That means some numbers or digit will be same. The number of permutations of n things taken all at a time when p of them are like of one kind, q of them are like of second kind, and r of them are like of third kind, and the rest are all different. This equal to n factorial divided by p factorial into q factorial into r factorial. For examples, the word Bangladesh. Here how many letters? Total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 letters. All are different? No. Here 2 used 2 times. A used 2 times here and here. That's mean A used 2 times. So we have to divide total number of permutation divided by 2 factorial. Clear? And 2s and others all are different. Therefore total number of permutations or arrangement, this equal to 10 factorial by 2 factorial, this equal to this, by using this formula. Another examples, the word Dhaka. Here how many letters? Total 5. All are different? No. Here A used 2 times. So total number of arrangement will be 5 factorial divided by 2 factorial, this equal to 60 was. Clear everyone? Problem, show that the permutations of the letters of the word Rajshahi taken all at a time is 4 times the number of permutation of the letters of the word Borishal taken all at a time. So at first you have to find the number of permutations of the letters of the word Borishal. Here total letters 1, 2, 3, 4, 5, 6, 7 and all are different. No, here to use, here A use 2 times. Okay, therefore the number of permutations will be 7 factorial divided by 2 factorial is equal to this. Again the word Rajshahi consists of 8 letters of which 2s and 2s. Therefore number of permutations will be 8 factorial divided by 2 factorial into 2 factorial. This is equal to 10,080. But 10,080 means 4 into 2520. 2520 means total number of permutations of the letters of the word Borishal. That's mean the permutation of the letters of the word Rajshahi taken all at a time is 4 times the number of permutation of the letters of the word Borishal taken all at a time. Short. Clear everyone? Assessment. Like as before solution. So I think that everybody will solve problem 1 and 2. Okay. Permutations involving repetitions. The number of permutations of n different things taken are at a time when each of things may be repeated up to r times in any permutation is n to the power r. For examples, the number of 3 digits can be formed using 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's mean you have to use this digit, but the number will be 3 digits number. Okay, and this equal to 9 to the power 3. For clear concept, follow the diagram. As the number will be 3 digits number, so first place can be filled up in 9 ways because you can use all the numbers. Second place also fill up by 9 ways because the number will be repeated or not. And finally third place also 9 ways we can fill up because the digit may be repeated. Okay, that's mean first place 1, second place you can also use 1, third place you can also use 1, no problem. Or first place 1, second place 2, third place 1, or first place 9, second place 8, third place 9, no problem, you can use because all places will be repeated or not. Therefore first 3 places can be filled up in 9 into 9 into 9, this is equal to 9 to the power 3 ways, and the numbers will be like as 1 2 3 or 1 1 5 or 8 8 8 or 7 7 7 or 1 5 7, etc. Clear everyone? Problem. The digits from 0 to 9 are written in a telephone dial. If the telephone numbers of Dhaka are 5 digits, how many telephone connections can be given in Dhaka where the telephone number not starting with 0? Follow the solution everyone. As the first digits not starting with 0, so first place can be filled up in 9 ways because 0 to 9 total how many digits? 10 digits. So first place can be filled up in 9 ways and total digit will be 5. So second, third, fourth and fifth, all places you can fill up from 0 to 9. That's mean 10 digits. You can use 10 digits. Okay, now follow the solution. There are 10 digits from 0 to 9. At the first place can be filled up in 9 ways, since 0 cannot be placed at the starting place. Any one of the rest 4 places can be filled up in 10 ways. Therefore, total number of telephone connections 9 into 10 into 10 into 10 into 10, this is equal to 9 into 10 to the power 4. This is the record answer. Now homework. Solve the problem related to the lecture and submit the copy in the group. Okay, and date of submit 7/7/2020, time 9 p.m. Everybody will submit at a time. Okay, remember this today up to this. Thank you to all everybody. Goodbye.